All right, so we're on problem 16, part A of the final exam practice, and we want to sketch this polar curve r equals 2 theta. So the way that we're going to do this is just by going to our calculator and making sure that we go to mode and that we're in the polar curves setting. And so then we'll go to our y equals window. We can put sine 2 theta as any of these r values. It doesn't really matter which one you do. I happen to put it as r2. We want to go to our window and make sure that we're graphing from theta min 0 at least through theta max equaling 2 pi. So that's what that value is, but I'll just write it in case. So we want to have theta max as 2 pi. Make your theta step small, so 0.1 should be sufficiently small. X min, X max, -1 and +1. And then your Y min, Y max is -1 and +1. The Y scale, X scale, doesn't really matter all that much. It's just set as default at 1. So either way, we graph this and we produce this beautiful flower. So either way, we would just sketch this graph here. And so I'll just talk about a couple of the features of this graph. So we start at 0, at theta equals 0. We come out, hit a maximum value of 1, and then come back. Now at theta equals pi over 2, sine takes the value sine 2 times pi over 2, so that would be sine of pi. So again, takes the value 0. At that point, it becomes negative, and so instead of going into the second quadrant, it actually goes into the fourth quadrant, and we draw another petal of our flower. Comes back to 0 at theta equals pi, because then we're looking at sine of 2 pi. Sine of 2 pi is equal to 0. And then it goes into the third quadrant because it becomes positive again. Draws another petal, comes back to 0 at theta equals 3 pi over 2. And then it would be in the fourth quadrant, but it actually, r will be negative, so sine is negative for these values of theta between 3 pi over 2 and 2 pi. And so then it will be in the opposite quadrant, so in quadrant 2, and we draw another petal of our flower there. And so this is our sketch of the polar curve, r equals sine 2 theta.